.NET Application Modernization, a 5-phase roadmap from legacy to cloud native. Hey, welcome. In this video, we're breaking down .NET Application Modernization, a 5-phase roadmap from legacy to cloud native. Let's get into it. Next up, why .NET Application Modernization can end #39. Wait. The business case for .NET Application Modernization becomes concrete when you quantify it. Microsoft ended mainstream support for .NET Framework 4.6.x and earlier, and while extended security updates exist for some versions through 2032, those cover security patches only, no performance improvements, no new runtime features, no Linux or container compatibility. Teams on these stacks are frozen while the rest of the ecosystem moves forward. The most visible cost is infrastructure. .NET Framework apps require Windows Server, which carries a licensing premium that Linux-based containers don't. On Azure, a D4 SV5 running Windows costs roughly 40% more per hour than the same spec on Linux. For a fleet of 20 application servers, that premium reaches $80,000 to $120,000 per year before storage and networking. Let's talk about now, Phase 1, assess your legacy app modernization baseline. You cannot plan a migration without knowing what you are migrating. Phase 1 builds a complete picture of your application portfolio before anyone writes new code. For any .NET application modernization program, this assessment prevents the common mistake of migrating the wrong applications first. A skilled enterprise application development team separates the modernization candidates from the retirement candidates here. Score each application across 4 dimensions: business criticality, technical debt level, change frequency, and cloud readiness. A 1 to 5 scale works well. Applications scoring high on business criticality and high on technical debt are the highest priority candidates. Applications scoring low on both are retirement or consolidation candidates. Most enterprises find 25 to 35% of their portfolio could be retired entirely. Doing this analysis upfront reduces modernization scope and makes the remaining phases cheaper. Next up, Phase 2, architect for .NET microservices and API-first design. Architecture decisions in Phase 2 determine whether your migration reduces technical debt or creates new varieties of it. This is where .NET microservices consulting experience makes a measurable difference, and where working with an experienced .NET development company pays for itself and avoided rework. Not every .NET monolith should become 30 microservices. The failure pattern we see most often is teams decomposing along technical layers rather than business capabilities. Domain-driven design gives you the vocabulary to decompose correctly, identify bounded contexts in your domain, then let those contexts guide service boundaries. For a logistics platform, that means separating order management, carrier routing, and billing into distinct services because those domains change at different rates and are owned by different teams. For a healthcare application, clinical workflows and patient administration typically have different regulatory requirements that make them natural service boundaries. Now, Phase 3, execute the .NET 9 migration with zero downtime. The migration phase is where most .NET application modernization programs succeed or stall. A .NET 9 migration requires a concrete sequencing strategy, not just a list of breaking changes to resolve. The strangler fig pattern works by routing new traffic through new .NET 9 components while legacy .NET Framework components continue serving existing traffic. You shift load gradually using a reverse proxy. In practice, identify the service with the lowest coupling and highest change frequency, build it on .NET 9, route 5% of traffic to it, validate behavior and performance, then increase to 100%. Retire the legacy component. Repeat for the next bounded context. Microsoft's official .NET porting documentation covers the compatibility analyzers that surface breaking changes before they reach production. Next up, now, Phase 4, front-end modernization with Blazor development services. Front-end modernization is most effective when sequenced alongside the back-end migration, not deferred as a separate project. Blazor development services have matured substantially with .NET 8 and 9, and for teams already invested in the C# ecosystem, Blazor is a serious option for enterprise web UI. Blazor Server renders UI on the server and pushes updates to the browser via SignalR. It's ideal for internal enterprise apps on corporate networks where server-side control is preferred. Blazor WASM runs C# directly in the browser via WebAssembly, making it suitable for public-facing apps where server round-trip latency would visibly hurt the experience. The Blazor render mode system in .NET 8 Plus lets you mix both models within a single application, selecting the approach per component. Our post on Blazor versus React for enterprise apps covers the full decision criteria, including when the component ecosystem gap actually matters for your project. Let's talk about now, Phase 5, operationalize with DevOps, observability, and governance. Getting to production on .NET 9 is not the finish line. Operationalization determines whether the modernized system delivers measurably better outcomes than the legacy one. A modernized application without automated deployment pipelines is just technical debt of a different kind. The pipeline should cover unit and integration test gates, Roslyn static analysis, container image builds with vulnerability scanning, staging deployment with automated smoke tests, and production deployment using Canary or Blue-Green strategy. Both Azure DevOps and GitHub Actions support .NET 9 natively. Our comparison of Azure DevOps versus GitHub Actions covers which tool fits different team structures and regulated industry compliance requirements. Next up, how long does .NET application modernization actually take? The honest answer is that it depends on scope, but there are reliable ranges. A single line of business application with 50,000 to 100,000 lines of code and 3 to 5 natural service boundaries typically completes all 5 phases in 4 to 6 months when resourced correctly. A full enterprise portfolio with 15 to 20 applications is a 2 to 3 year program structured as a series of shorter delivery cycles. The biggest variable is organizational readiness, not code complexity. Teams with automated test coverage migrate 30 to 40% faster than teams starting from zero. Database schema complexity is the second largest factor. Applications with 500 plus tables and significant stored procedure business logic consistently exceed initial estimates by 30 to 50%. Any .NET development company worth engaging can give you a defensible timeline estimate after a structured 2-week discovery sprint. Any number quoted before that discovery work is guesswork, regardless of how confidently it is delivered. Let's talk about what is the Strangler Fig pattern for .NET application modernization. The Strangler Fig pattern is an incremental migration approach where new functionality is built on the target platform while the legacy system continues running, with traffic gradually shifted from old to new until the legacy system can be safely retired. Named by Martin Fowler, the Strangler Fig pattern is the dominant approach for legacy app modernization because it eliminates the need for a high-risk cutover event. Legacy .NET Framework modernization uses this pattern to incrementally replace components without a full rewrite, maintaining business continuity throughout. YRP is the preferred .NET native routing layer. It's built on .NET 9, configurable in C#, and integrates cleanly with existing ASP.NET Core middleware. The typical cycle per bounded context is 6 to 10 weeks for a medium complexity service. Next up, common pitfalls in enterprise application development modernization projects. Even well-funded enterprise application development initiatives stall. The failure modes are consistent enough to predict in advance. Over-engineering the target architecture. Teams design for 10x their current load before the new services have served a single production request. This adds months of infrastructure work that delivers no immediate business value. Build for your actual load with reasonable headroom, then scale when metrics tell you to. Skipping observability until the end. Distributed systems without tracing and structured logging are debugging nightmares. Teams that defer observability work spend 3 to 4 weeks retrofitting it after services are already in production, and that retrofitting is harder than building it in from phase 3 forward. Now, moving on to conclusion. .NET application modernization is fundamentally an organizational sequencing challenge with a technology component. The 5 phases in this roadmap give enterprise teams a credible incremental path from .NET Framework to cloud-native .NET 9 without the big bang risk that ends most rewrite programs before they deliver. The teams that succeed use the Strangler Fig pattern to migrate incrementally, invest in observability from the first service boundary, maintain human governance checkpoints throughout each sprint, and treat each phase as a discrete delivery with measurable outcomes. Whether you're evaluating ASP.NET Development Services partners or building .NET Microservices consulting capacity in-house, this structured approach separates 6-month programs that ship from 2-year programs that stall. Q Services specializes in .NET application modernization for mid-market and enterprise teams in healthcare, logistics, banking, and SaaS. Our 5-day blueprint sprint is the fastest way to get a realistic scope, timeline, and cost estimate without committing to a full engagement.